Hey guys, thanks for tuning in. Today, we're going to do an unboxing setup and initial print on the Longer LK4. All right, let's just cut it open. So it's almost impossible to do an unboxing setup of this without drawing some similarities or at least some comparisons with the Ender 3, considering they're almost identical in format and in build volume. So we have a small piece of sample filament. I'm not going to use that, I'll use a normal roll with the instruction manual. The color touchscreen, I think it's 2.8 inches or so. One set of wheels and a belt, so this will ride up and down the Z. Two 2020 extrusions, one's going to be for the top of the frame and the other for the X-axis. USB adapter for a micro SD card, some assembly tools. There's an end switch, some zip ties, this little metal plate, a standard looking spool holder, and then some of the bigger parts. Okay, so there's the base, the heated bed is attached as well as the hot end assembly. So this will be the X-axis motor and the extruder here. So they're using what looks like 2040s, but on one side it's got the normal grooves, and then on the other side it's got this solid flat surface. So it's a little bit different than a normal extrusion. Lead screw. The Z motor. And I think there's one more 2040 here. And that should be it. Okay, before we get assembling, I just want to correct a couple things. I glossed over a couple of the parts that were in the box, so be careful. Pull out all the pieces of styrofoam, and underneath them you might find a bag like this of the springs, as well as the Z coupler for the lead screw. But everything else I've already identified. The other thing is that this bed was actually just kind of caught on here with the plastic. The bed is completely separate, and it just uses a quick connector, like a plug, to plug the cabling into the back of it. But it does look like we're going to have to put the springs and the screws through there to attach it to the carriage here. So I'll set that aside for now. So the first thing, as is typical, we're going to install the uprights. They bolt up through the underside of these flat pieces here, and they're slightly different. One of them has two holes in the bottom here. Those two holes are going to be for our Z motor to bolt to, and those are going to therefore go on the left side if you're facing the front of the printer. The other one, doesn't matter what direction it goes, it's going to go like this. Now, as I'm bolting under here, I'm going to leave it loose until we assemble and slide on the entire kind of X assembly. And then we'll make sure that that's moving smoothly in case we have to make any adjustments to these, and then we'll come back around and firm those up. So 4 of these M5 by 20 bolts, 2 in each side. So now one of these two is our top, and I'm going to guess that it's the one wrapped in plastic. So one of them has a lot more holes in it than the other. So the one with only 4 holes, 2 on each side, is for the top here. Now we're not going to add that on now because we do have to slide the rest of the assembly over top. So that means we want the one with more holes, a bunch of small holes in this one. And this assembly will be on this arm over here, and will bolt onto this guy. So the way that the two of these get assembled, there's one side with 3 holes, 2 small, 1 large. This one large drilled out area is to accommodate the head of this bolt here. So we'll put it like this, and the other two holes line up with these two. Those holes in the 2020 are tapped, so we're going to screw from in here. We're going to put two of these M4 by 16 screws. It's kind of awkward, but place them in the middle and then down through the holes. And then on the back side here, we can run an Allen key through there and tighten that guy up. Okay, so I've got the first one, still very loose, so I can position and align the second one so I can get that in there too. But the first one's always the hardest. So that looks pretty good. I kind of use the top of the bracket here to make sure that things are all flush so that you can tell that this is not on a major angle, because there is some play in those holes, and it's pretty much flush here. It's at least equally spaced the whole way along, so it shouldn't be angled. And then the other side, a little bit simpler, it's just wheels. And I would assume this is going to go this way. Yep. A similar fashion. Yep. So again, there's a larger drilled out hole for this bolt here. One wheel goes on the inner side, two on the outer, and then we'll be able to drop screws through these other two holes, there we go, into the threaded drilled out holes in the extrusion there. So now that we have this entire assembly here, we can slide it down over top, obviously making sure the extruder is on the right-hand side of the printer. Slide smoothly. And I'll just leave that down there, and at this point I'm just going to firm up each of the screws that hold those uprights. Okay, at this point I'm going to start assembling the Z-axis lead screw components so that we can hold this whole thing up. So as I mentioned, I've now turned it around so we're opposite left and right, but from the front of the printer, the left-hand side here that has all of this, this is where the holes are for the Z-axis motor assembly. And we're going to screw through here, and it's threaded. Put that guy down gently there. We're going to use these M4s, which are the same ones we use to attach the X-rail to the rollers. And just bolt that guy on. So with that done, we can unwrap this lead screw. And before installing it, I'm just going to double check that it's flat, not warped or anything. Straight, not flat. All right, well that took a little while, getting the saran wrap off there. Let's clean up a little. Okay, now that I have that off, rolling this on a table shows that it's flat. Yep, it looks fine. So you'll normally tell it'll go like whoa, 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 whoa. So here we go. Slide this down through the top here. They've greased this coupler quite a bit there, so that'll get all over the lead screw as you send it down. All right, so now it's in there. And we'll tighten the grub screws on the coupler here. There are two of them. Okay, so now those are attached, that's done. The X carriage assembly here. So we've got looks like a 4010 axial fan with a 3D printed shroud. This looks to be like an MK8 style hot end with the pinch type thermistor. So this guy, probably route this cable a little bit better. There. So we'll slide it on this end here. And we may need to actually loosen some of these wheels a little bit to get it on. So don't do as I did. I would suggest putting this on before we actually attach the wheels, the carriages to the end here, because the screws here have now scratched the side of this. So installing that earlier might be better. If you are at this stage and you want to install it now, I would just suggest unbolting these top two wheels, and then you can just slide it right on here and then bolt them back on. You don't have to try to slide it past there. So before we go any further, let's untangle some of this. We do have a ribbon cable. It's coming out of the side of the control box, which is at the back here. There's also the cable for the heated bed in this plastic corrugated wire loom stuff. The Y-axis motor is already connected, as is the Y-axis limit switch. And then this is obviously for the hot end assembly. And then the little pile of cables coming out here are for the, well, they're labeled as is typical. So there's extruder, there's X-axis motor, which is this. There's going to be the X-axis limit switch, which is just the smaller one labeled X. I'm just going to go under here. There's the limit switch. And then there's a E small and E large one. So the E large one goes to the stepper motor for the extruder. And then the small one is for the filament runout sensor, which is over here by the lead screw. This is the filament runout sensor. It seems to be an optical filament runout sensor, so contactless, instead of the typical micro switch. There we go. Some of these are a little bit tangled. Yeah, that's better. Okay. And then the Bowden tube here is going to connect into the coupler on the extruder. Slide that all the way in. It'll bottom out and then give a little pull. Make sure it's secure. All right. So now we're going to need a belt. We have no way for the X-axis motor over here to move the hot end assembly. So this belt is going to route underneath the wheels. There we go. And then over top of the toothed pulley attached to the X-axis motor. And then all the way back on the underside. And then on the underside of the assembly here, this is where it connects to these little arms that I'm holding on to, one on either side. And there's no notch in it or anything, so we'll wrap it around and then we'll zip tie it. So I flipped this around so you can see a little bit better, but effectively what we're going to do is pinch the teeth onto themselves, which locks it in place, and then zip tie that so that those teeth don't slip. We're just creating a little loop there. And zip tie it as tight as you can. And we'll do that twice just to be sure. And then snip those off. All right. So now this little loop that we've created is going to go over this finger, for lack of a better word, right here. Just make sure that you don't, twist the orientation of your belt. Slide that over there. Good. And then making sure that the belt is still on the tooth pulley on this side. We don't have a tensioner on this side yet, so it's just going to be hanging off the end of the 2020 extrusion. And you can see we have lots of spare belt here. We don't need to be too tight because we are going to apply pressure to this end with a tensioner. But you don't want to leave tons and tons of slack either. So I'm just going to kind of eyeball it. Actually, you know what? Better than doing that, I've mentioned it, but we're gonna put the tensioner on here, and we'll leave the tensioner completely loose to give us a better idea of how much extra belt we really do have. So this is the tensioner. This is going to bolt onto here, and it allows us to make some adjustment in how much pressure is put against the belt to make it nice and tight. That's why there's these little slits in here instead of just being circular holes. So these M4s again. There are 3 spots that we can screw into, it looks like here. I'm intentionally leaving this extremely loose. I want it to be as loose as possible, so all the way that way. Run the belt over top, and then that tells me kind of how much spare belt I really do have. And the pressure that you put against this will stretch the belt out and tighten it even further. So as long as you're, tight-ish with this all the way loose, then you'll be nice and taut when you extend the tensioner. So I'm, again, eyeballing how much I need to fold it over, tightening it as much as I can with my hands, keeping the teeth like that against each other so it doesn't move. And then I'll put 2 zip ties, leaving a nice loop at the end to slide over that finger. And then once I'm sure I have everything set up well, I'll probably snip off the extra length of belt. Snip off the extra. Just confirming that it's still on the toothed pulley on the motor side. Slid over just fine. And then I still have plenty of adjustment here. I'm not even going to need all the adjustment that I have because it's plenty tight, about halfway down the adjustment that is available to me. So keeping pressure with my finger, tighten those. And you may want to adjust it, up or down a little bit. If the belt is rubbing on the extrusion, you may want this to be slightly up versus slightly down. You just definitely don't want the belt rubbing against anything if you can help it. So there we go. So now that belt is nice and tight. There we go. If you're moving it by hand like this, only move it slowly because we are all connected. So you could run voltage back into the stepper drivers and blow them if you move this too quickly. And in this case, we have a little bit of play. It's not wobbling, well, a little bit maybe, yeah. So we're gonna tighten the eccentric nut on the bottom wheel. So taking our wrench, the larger end, there are 2 smooth kind of bushings on these ones, but on this one there's the eccentric nut. So we can tighten it. It's always a guessing game of which way is tighter versus loose, but there we go. So now when I spin any one wheel with my hand, they all move. There's no more play in that at all. And there's no binding or kind of bumpiness as I roll it along. So that's a good amount of tension. And for the y-axis here, we also have eccentric nuts. They're on this side. In our case though, it's pretty firm. Now's a good time to do it though, since we have easier access before we put on the heated bed. It's a little loose on this back one. As I was spinning the wheel by hand, it wasn't even making contact with the extrusion there. There we go. And all it takes is a tiny amount of adjustment to make firm contact. There, still no play, moving smoothly. Okay, so we can put on the top rail, why not? And in this case, it does have bored out larger holes on this side. This side just has kind of the inner hole. So the larger hole at the top here allows the head of the bolt to go in, and it goes this way with the smooth part facing outwards. And once again, we're going to use the M5x20 bolts. Same ones we use to bolt these uprights on the bottom. We'll use it to bolt the top on. And just for cosmetic reasons, I'm making sure that these are nice and flush on the front. It is kind of nice having these flat surfaces, especially on the horizontal ones, so that little bits of plastic as you're, say, scraping something off the bed, or if you have a purge line, sometimes when you pull those off, it breaks into small pieces. Any of that debris doesn't end up stuck in the channels of the extrusion. It'll just be on top or fall onto the table and be easier to clean up. Sometimes I find I need to get a vacuum out to vacuum the little bits of plastic out of the aluminum, because it drives me crazy. All right, starting to look like a printer. So at this point, I think maybe we'll do the LCD screen. There's really no rhyme or reason to the order in which I'm assembling most of this. So the LCD screen is where the ribbon cable is going to connect to. If you're not familiar with these types of connectors, the dark bar here kind of slides in to lock it, and then it slides out and rotates up to allow the ribbon cable to come out. Other types of ribbon cable are just friction fit with none of this latching mechanism. So in our case, we have this large ribbon cable, and one side is blue with a little tape, the other side actually has the pins. So in our case, the pins are going to be face down like this. Slide them all the way in the connector, slide the dark part of the connector down, you'll feel it click. And in this case, it doesn't actually slide inwards to lock, it's just clicked down. And then to release, you would just flick it up and then pull the ribbon cable out. So now that I've connected it, let's find out where they want us to install it. I'm going to say it's on this side, considering they left the caps off on this side and these are threaded to allow us to maybe bolt this on there like that. Let's take a look at the manual. Gladly, I looked at the manual. This little metal cover is intended to cover the back side of the screen to protect some of the circuitry, I suppose. So they show it on there like that. So using the bolts that are holding on the circuit board, they want it like that. It has a bit of a cutout here to allow the ribbon cable to come out, whereas the other side is completely solid. I'm not entirely sure if that's required, but you know what? They show it in the manual, so let's just follow the manual. You do have to connect the ribbon cable before you attach the silver cover, otherwise you're going to have a very difficult time getting those two connected. So for the screen, there are two M5x6s in a separate little bag here, and they are going to allow us to bolt this on here like that. Interestingly, they do have 4 holes on the front, but we're only going to use 2. I guess you could do this kind of ambidextrously if you wanted to have it on this side, just pop these off. They may be threaded as well. So there's certainly enough ribbon cable here for us to run this screen off of this leg if we so chose, or I mean, put it elsewhere for that matter. I'm not sure how we're gonna kind of deal with this from a cable management perspective, but we'll deal with that in a second. When I was previously connecting the cables, I didn't connect the Z motor. So the one labeled Z here, the larger one is for the Z motor. And then we're gonna have a smaller one for Z limit switch. The Z limit switch, this guy in this bag, there's a hammer nut attached to it. Grab the right Allen key, that one. And this is going to go in the side of the upright. So in here, they show this being placed like this, and then just spin it so that the hammer nut engages. And then we can connect the wire to him. Okay, so that should hit something under here. Usually we have them on the front, but in this case, just because of the smooth front design. If we slowly lower this, we can test, number one, if this is high enough, and number two, if it actually makes contact. Okay, so the wheel itself actually hits the limit switch, which is perfectly fine. We'll probably need to adjust it once we have the heated bed on there, because that's going to add some height to the assembly. Okay. So let's start unwrapping the heated bed. So the heated bed assembly, as I mentioned earlier, has a quick connect plug on the back. It has looks like a glass surface, just with binder clips attached to the heated bed. So there's the aluminum heated bed. And this is a glass surface with this kind of build tack material bonded to it. And some warnings about don't touch it, it's hot. But for now, all we care about is this, because we have to add the screws and the springs to bolt it to the carriage here for the Y. So in the bag with the springs, we have obviously 4 of these flat coil springs, the little knobs, the adjustment knobs for them, and then long bolts to go through here. Pretty simple assembly. Drop a bolt in, put a spring on, and then we'll slide it onto the carriage and then bolt these little knobs underneath. This is definitely going to be kind of tricky to show you properly, but I'm going to do 2 at a time. I'll do the front 2 just because they're the easiest to access without dropping the springs. And now there are actually 2 holes drilled in the carriage. We're using the outer of the 2 holes. The other 2 won't line up properly, but just so there's no confusion, use the outer holes. And then for the back ones, I'll just place the spring on top of the screw, slide it through the hole as well. And then one last back corner here. There we go. So then just holding the top of the screw with like a finger, or you could grab an Allen key so it doesn't move around. Put some tension on them with these little knobs. Back ones are probably easier if we just extend it all the way to the back. So now, I'll just reattach the plate there. And we may as well plug in the heated bed. It's got a nice locking tab on that, so that's a real secure connection there. All right. I think we're about ready to turn it on. We might need a spool holder. And in this case, the spool holder is probably going to go over here. Yes, it is. So right behind the Z motor, there are 2 threaded holes on the top of this extrusion, and figure out what orientation this goes in. There, like that. It lines up perfectly with these 2. So the spool holder is going to go like this, which is interesting because it holds the spool on a bit of a 45. Last bag of screws, M5 by 16 screws. There's 2 of them. We'll use these to bolt this guy on. There we go. So as I was assembling that spool holder, I just realized something kind of interesting. We're used to, say, the control box being up at the front. We've got the power supply underneath, and we've also got the control box at the back. And therefore, the USB connection and the micro SD card are actually at the back of the machine. It might be a lot more convenient if it was, say, in the side of the screen or somewhere a little more accessible. But it is what it is. So now I'm gonna clean up my work surface and we're gonna start a couple of the test prints. All right, so let's plug it in. The plug is on the back and there is a toggle switch. There we go. It lit up. Everything seems to be okay so far. One thing that I noticed as I was kind of going over it once more before we print, check all my wheels, check all my bolts are tight and everything. I didn't adjust the eccentric nuts on the Z, technically here. The outer wheel here is just spinning free with no pressure against the rail. And there's really not a whole lot you can do on the Z. I mean, you can tighten the eccentric nut, but at a certain point in time, it's not gonna make any difference. So we have 2 of 3 wheels making very good contact. And on this side, we have 2 of 3 as well, making good contact. If I tighten that eccentric nut more, it's just gonna wear out this inner wheel faster. That could mean a couple things. It could mean something's out of alignment, so I could take it down and rearrange that. Specifically, the alignment between this wheel assembly and the 2020 rail. So those screws, if I loosen them, there'll be a little bit of play. And I kind of talked about keeping the 2 of these flush with each other to make sure that they're not on an angle. There could be a slight angle there. In this case, it would be angled that way because this wheel is the one that's loose. The other 2 have pressure. So if I loosened that and kind of twisted it back this way, it would put pressure between this and the rail. But for now, I'm gonna leave it. I know that it's probably not gonna cause me any kind of grief. And I think we should take a look at the screen, check the standard motion, X, Y, Z, homing. We will need to adjust the height for the Z limit switch. If I move the Z down, we're probably not gonna contact it in time. Nope. We touch the bed and the limit switch is still about a centimeter or so away. So we'll have to unplug the limit switch to get to the screw and then loosen the screw, slide the switch up until it's contacting. We can leave it a little bit extra down because what I'm going to do is tighten the screws all around on the bed to lower the bed as well. And then reconnect that guy. So now you can hear it touching the limit switch. Whoops, cord came out. Here. You can hear it touching the limit switch before the nozzle contacts the bed. So with the printer on, and I've already checked to make sure that we have enough clearance with the Z, I'm gonna move the head around. And so you can home the individual axes, X, Y, Z, or home all. In my case, I'm just gonna home Z. Okay, so Z works. I can also change the increments, so I'm doing this in 5mm increments. If you just tap there, it'll go to 10. So if I do Z+, it should have raised it 10mm. I'm gonna check the X, moves both ways. Y moves both ways. And so I may as well just home them all. Okay, so with them homed, I'm going to heat everything up. So let's go to preheating. And this is the nozzle and the heat bed. So I'm gonna set the heat bed to, say, 50 degrees. And the nozzle, set it to 210. There are also presets at the bottom. As you can see here, PLA, ABS, and PET-G. So PLA is set to 260, ABS set to 230 and 80, PET-G, PET-G is 215 and 70. So we'll do the 260 for PLA, let that get up to temperature. Okay, it's all up to temperature. And just to be safe, I'm gonna tighten down each of the corners a little bit further so that we don't ram the nozzle into the bed as we go around and level the corners. That should be good enough. Okay, so if we get out of this menu, we can go to more and then leveling. Oops, here. And so it's got some quick points for the corners as well as the center. So we'll hit this front left corner. And because I've tightened everything, there's tons of space. So I'm just gonna loosen the knob on the corner until there's some drag. And then we'll go around and do this corner to corner. Once you've done that once, you should go around and do it a second time, because as you're changing each corner, you're influencing the others. If you find that you have to loosen a corner too much, where there's no more preload on that spring and you don't feel any tension on the knob at the bottom, that means you should probably adjust your Z end stop further down so that you can put more compression on those springs and bring the bed further down as well. Once I've done all 4 corners, I also go to the center. I like this option. I usually enable this in Marlin myself to be able to check to make sure that it's also the same amount of drag in the center of the bed. Now, because I haven't done a second time around, I can see the center of the bed is super tight. So I'll go around a second time. Likely some of the corners need to be tightened a little bit. So I've loaded the filament in the back and reached around back and put in the micro SD card. Here we go. And so on the screen, if we go to files, we can see some test print files that they've sliced up for us. I have no idea what these are, but I feel like printing a bird. Choose bird. There's also 2 pages worth, so page 2 has nothing. So we'll print a bird. We'll hit open. Are you sure you want to start printing? Yes. All right, it says about 3 hours and 33 minutes. We're back. So last thing you saw, I was printing birdies. We used our black PLA, not the PLA that it came with, but it prints in the same temperature range. So this is probably a good example of it. There was a little bit of stringing between some of the ears here, but again, we didn't slice this. This is their slice, and on a raft, as is kind of typical for some of their pre-sliced stuff. But generally speaking, it looks good. There's a little bit of layer stacking issue here. Not exactly sure what would have caused that, so more investigation there. And then the next was a benchy boat. Again, one of their pre-sliced files on a raft. And these rafts never come off nicely. I'm not a fan. I would just use a brim at the very most, but regardless, it turned out okay. It does show us that we have a little bit of salmon skin effect, which is as a result of the stepper drivers that were used. They are onboard stepper drivers, so they're not easily replaceable without swapping the board. So it looks like a great upgrade for this would be TL smoothers, which should help eliminate or at least significantly reduce the amount of salmon skin that we see on flat vertical surfaces like that. But we don't see the kind of layer stacking issue on the hull here that we saw on the other model. There's a little bit of drooping at the top of the door frame there, the doorway. And there is a little bit of under extrusion in a couple layers here along the side. So I'm not sure if we had like a micro clog or what happened there. But it just seems like somewhat random and only on the upper part of this model. So it may have to do with the retraction settings actually, because there will be a lot of retracts there as it goes between the doorway. And then a cat, again, another pre-sliced model. This is in a filament that we're testing currently. I can't really talk about it, but we're not very familiar with this filament, so I won't hold anything against their pre-slice for this, but it does work in the same temperature range as they had chosen for their slice. This turned out quite well. There is, again, a little bit of layer stacking issue here where there's like a texture instead of them being kind of buttery smooth. But generally speaking, this turned out fine. We don't have any sags, not even at the tip of the nose here or the eyebrows or anything like that. So I'm happy with how that turned out as well. So hopefully you found this useful. Remember to like and subscribe and leave a comment down below, or if you have a question about the Longer LK4 or any other printer you've seen on our channel. Thanks for watching.